The Sunda Strait Bridge. The Sunda Strait Bridge is a mega project that will connect the islands of Java and Sumatra in the western part of Indonesia. Due to the very deep seabed profile that reaches 135 meters below sea level, the bridge will consist of two ultra-long-span bridges, one crossing the eastern basin that we will call the East Bridge, and the other spanning the western basin that we will call the West Bridge. This linked bridge will also have two approach bridges, one on the Java side and one on the Sumatra side, as well as a viaduct connecting the two long-span bridges passing through Sangiang Island. The Sunda Strait Bridge is a combined railroad bridge that will provide both highway and railway traffic lanes. The highway will allow for two-way traffic with 3 vehicle lanes 3.6 meters wide and 1 emergency lane 3 meters wide, as well as a 1.5 meter wide inner shoulder. Meanwhile, the railway system will consist of a double-track light rail passenger transport system. Due to the aerodynamic stability aspect of ultra-long-span bridges, the bridge deck will utilize a double-level deck system in which the highway lanes will be set on the upper deck while the railway tracks will be placed on the lower deck. The bridge deck will vary in width from 48.6 meters to 51.8 meters wide. In addition, the approach bridges and viaduct will consist of 3 parallel balanced cantilever bridges using a concrete box girder system, each with a span of 150 meters, with girder height varying from between 3.2 meters and 8 meters high. The East Bridge will have a main span length of 2,016 meters and a total length of 3,600 meters, with 320 meter high pylons. The clearance above the sea level will be 85 meters. Meanwhile, the West Bridge will have a main span length of 1,224 meters and a total length of 2,052 meters, with 220 meter high pylons. It will also have a clearance above sea level of 85 meters. Considering the aerodynamic stability aspect, in our conceptual design, the long-span bridge deck is proposed to be equipped with an aeroflow system in the middle of the deck to improve the aerodynamic performance of the bridge. Ultra Long-Span Bridge Foundation. A caisson-type foundation has been chosen as the foundation for the ultra long-span bridges, which will be prepared as follows. First, the seabed surface is improved using a pile driving system and gravel ballasting. Then the hollow caisson is fabricated using reinforced concrete in the dry dock yard. Next, the hollow caisson is transported from the dry dock yard to the wet dock yard to facilitate installation and pouring of concrete in the upper part of the caisson. The caisson is then transported from the wet dock yard to the foundation site. The concrete piers are then poured. Installation of formwork, placing of rebar, and pouring of the concrete pier heads follow. After that comes the installation of formwork, placing of rebar, and pouring of the bridge tower and cross beams. The same sequence is then repeated for the construction of anchor blocks. After that comes the erection and saddle placement on the top of the bridge towers, followed by installation and saddle placement on top of the anchor blocks. Guide cables are then installed. This is followed by the installation of the working platform using the guided cable system. The next stage is the main cable system. First, the main cable is installed. The main cable is then anchored. This is followed by the installation of cable clamps. Then hanger clamps at the main cable are installed. Next comes the installation of the hangars. After that, the prefabricated steel deck segments are put into place. And finally, the deck segments are joined into a continuous bridge deck system. Approach bridges and the viaduct. Boring work will be carried out using a boring template to achieve precise and accurate borehole. Then, drilling will be conducted using a steel pipe casing to the designed depth. Followed by installation of rebar and pouring of the bore piles. This will be followed by installation of formwork, placing of rebar, and pouring of the pile caps. The installation of the precast concrete deck will follow. After that, the precast concrete deck segments will be joined permanently for 5 consecutive segments. Finally, the group of 5 continuous concrete deck segments will be joined using a one-directional movable closure. As the study continues, the aerodynamic performance of the Sunda Strait Bridge will remain a key research topic in further feasibility studies and even in the future detailed design stage of the bridge. Thank you for your kind attention.